Okay, so what if you could just tell your computer what to look for in a picture? I don't mean just searching for cat. I mean actually saying, the cat that's sleeping on the armchair. Sounds a little like science fiction, right? Well, today we're going to dive into a project that makes this reality, teaching an AI to truly see what we're talking about.
First up, I want to show you something that, honestly, it feels a bit like a magic trick. It's the perfect way to see what this project is really all about.
So let me ask you this. You've got a super cluttered photo, right? Stuff everywhere. How would you even begin to tell a computer, hey, find that one specific thing for me?
I mean, you could spend forever with cropping tools or maybe some complicated search filters, but what if you could just skip all that? What if you could just ask in plain English?
And here it is. This is exactly what I'm talking about. Someone just types in the cat on the sofa and boom, look at that. The AI draws a perfect box right around the cat. It completely ignores the dog, the pillows, all the other distractions. It didn't just find any cat, it found the cat on the sofa. That's the magic trick right there.
So how in the world does it do that? Well, it's not really magic, you know. It's this incredible technology called visual grounding. So let's pull back the curtain and see what's really going on behind the scenes.
At its core, think of visual grounding as the bridge between language and sight for a computer. It's the secret sauce that lets an AI hear a phrase like the cat on the sofa and then connect, or ground, those words to the exact cluster of pixels that form that object in the image. It's about making words mean something visually.
So what's the game plan for this particular project? Well, it's pretty clever. Instead of trying to build an AI from scratch, it takes two existing heavy hitters, a top-notch vision model and a killer text model, and then mashes them together using something called a transformer. Then, it trains this new combination on a very specific dataset that's just perfect for this kind of text-to-object task. Okay, let's get into the nitty-gritty. We're talking about the model's architecture. This is basically the blueprint of how this thing actually thinks.
So you can kind of think of this model as having two specialized brains working together. First, you've got the eyes. That's a beast of a vision model called DINOv3. It's a total pro at just scanning an image and soaking up all the visual details. Then you have the interpreter, a text model called BGE, which is amazing at figuring out what your words actually mean. And here's the kicker. Both of these are already experts, like superstars in their own right.
And this diagram shows how they get wired together. Check this out. See at the top where it says the models are frozen? That means we're not messing with our experts. Their incredible knowledge is locked in. The real action happens in that trainable section. That's the new part, a Transformer Decoder, and its only job is to learn one new skill, how to connect what the eyes are seeing with what the interpreter is reading. That's where the learning happens.
So that diagram might look a little intense, but it really just boils down to 5 simple steps. Ready? 1. The eyes. DINOv3. Scan the image. 2. The interpreter. BGE. Reads your prompt. 3. Some special layers act like universal translators, getting the visual and text data into the same language. 4. The Transformer Decoder fuses it all together, making that critical connection. And finally, step 5. A prediction head just spits out the final coordinates for the box. That's it.
So, remember that trainable part we just talked about? How much new brain are we actually building? Well, this much. Almost 26 million trainable parameters. That is a huge amount of learning capacity, and it's all dedicated to mastering this one very specific, very cool skill.
Okay, so the theory sounds great. The architecture looks cool, but did it actually work? Let's put it to the test and check out the results.
All right, this table basically shows the model going to school. Don't worry about all the numbers, just look at that last column, val IOU. Now, IOU is just a fancy term for how accurate the box is. It means intersection over union. Basically, how much does the AI's box overlap with the perfect box? And look what happens. After one training round, it's at about 43%. But by round 10, it's over 62%. You can literally watch it getting smarter.
And the final grade? The score on data it has never, ever seen before? A really solid 0.6196. So what does that mean in plain English? It means, on average, the box the AI draws has a nearly 62% overlap with the correct answer. For a task this complex, that is a seriously impressive result. But hey, numbers are one thing, but seeing is believing, right? Check these out. On the left, the prompt is the tiger hunting, and it absolutely nails it, totally ignoring that bird. And on the right, a cycle in the ground, and it finds just the bike lying down. This shows it's not just finding objects, it's understanding context. That's next level stuff.
This is awesome, for sure. But in the world of AI, you're always asking, what's next? So let's take a quick look at the road ahead.
So, where does a project like this go from here? Well, there are a couple of really exciting ideas. First, using a new training technique could basically force the model to get even better at telling right from wrong, really sharpening its understanding. And second, imagine feeding it totally different kinds of pictures, like medical scans or satellite images. You could turn this into a super specialized tool for doctors or scientists. The potential is just huge.
And that really brings us to the big takeaway here. This isn't just about some clever code or a cool demo. What you're really seeing is a genuine step towards computers that don't just look at pixels, but actually start to understand our world visually in a way that feels a lot more human.
This whole incredible project was created by some podcar. Seriously, amazing work. If you're a coder or just curious and want to peek under the hood, you can find the entire thing on GitHub. Just look up some podcar21/visual_grounding. It's a fantastic window into where AI is headed. Thanks so much for checking this out with me.